Alright guys, so today let's look at Leetcode problem number 300, longest increasing subsequence. So in this problem, you're given a list array, and you're asked to find the length of the longest increasing subsequence. Let's take this for example. So in this array, you have number 10, number 9, 2, 5, 3, 7, 20, 18. So we have this much number. They are not in ordered, so they are not ordered, so they are randomly distributed. So we want to find the longest increasing subsequence. So in this case, it's 2, 5, 7, 20, which equals 4. So the answer is 4. So it should be noted that this is not describing this is describing the longest increasing subsequence, not describing the longest increasing continuous subsequence. So the numbers is not necessarily to be continuous. So what's the signature of this problem? The signature is to find the longest. So it's a problem to find the minimum or maximum, and you are given a sequence. You are asked to find the subsequence problem. So this is a very typical dynamic programming problem. So let's have a look. So in sequence dynamic programming problem, so we should normally make sure that our function, our state is equals the something that ends with I. So in our case, our fi so denotes to the length of the longest subsequence ending at numbers I. So that's the state. What is its sub problem? Its sub problem is so if it ends with I, so we need to find the element right before I. Okay, so we just search. So you have Y, so we just search. So for example, let's just take this for example because it should be easier. So okay, right here we have this much number. So for example, if I is here at 7, so what is the possible longest subsequence length ending with 7? It's definitely not the element before 7 is definitely not 9, because 9 is larger than 7, so it's not increasing, it's decreasing. So it has to be either 2 or 5 or 3. So we just traverse the elements before I and find those elements that are less than 7, and we can find that. Then we should know that then f7 then equals f2 plus 1, right? Because f2 means the longest subsequence, the length of longest subsequence ending at 2, and also it could be f5 plus 1 or f3 plus 1. So we want to So we want to find the maximum. So choose the maximum of this. Okay. So that's the transfer function. What about the initial state? Well, the initial state. So initial state is fairly easy. It's f0 equals 1. f0 means the length of the longest subsequence ending at num0. So there's only one element, that's 10. So f0 equals 1. So let's implement this algorithm. First, let's do the edge case. If not nums, return 0. Length of nums. Length equals length of nums. Okay. Length equals length of nums. We need to define a dynamic programming. dp equals 1 times length d initialize it, dp1 dp0 equals 1, so that's already initialized. For j in range 1 to nth, for I in range j. So normally my habit is to if we need to do 2 for loops, my habit is to always make j the larger one while I is the smaller one in range of j. So that's a good habit. So okay, so for nums j is larger than nums I, then we should nums j is larger than nums I, then we should find the maximum. So we should update dp j equals maximum of dp j and dp I plus 1, and result equals max of result and dp j result equals 1. Return result. Okay, that should do it. Okay, good. So we may want to ask a question: if what's the time complexity? The time complexity is O(n) squared because we have 2 for loops. What about the space complexity? Well, the space complexity is O(n) because we need to define an array to store all the possible longest lengths for each element. So the follow-up question is: can we make the space better? Unfortunately, the answer is no, because this right here, dp j, not only depends on dp j is the one right next to it, but also all the ones that are before j. So we need to use every rows in the dp in order to find dpj. What about the time complexity? Here the time complexity is O(n) squared, which is not ideal. Can we optimize it? So actually yes, we can, but it's very difficult to do. so I'm not going to implement that in this video, but I'm gonna do it in the next video. Heads up for that is we are going to use binary search combining the dynamic programming technique to solve the problem using n log n time. But that's the task of next video. If you like this video, please upload my video or share my video to your friends or subscribe my video channels. My name is Jimmy. Thank you very much. Bye bye.